Surface tension.
With the help of a ripple tank experiment using a tuning fork of known frequency nu and measuring lambda by experiment, the value of surface tension T can be calculated. Now let us do the experiment. This is the experimental arrangement. The perfectly clean liquid is placed in a large flat dish A, such as a photographic developing dish or just like a plate. An electrically maintained tuning fork F of frequency 100 Hz is held in position above the liquid. The tuning fork is held horizontally with the prongs vibrating in the vertical plane. A dipper D of polished silver or aluminum is attached to the lower prong and its lower end touches this liquid surface in the dish. When the prong is set into vibration, the vertical to and fro motion of the dipper produces ripples in the liquid. So, when the prongs are vibrating in the vertical direction, the pointer attached to the prong also vibrating in the vertical direction. So, it touches the liquid, it produces ripples in the surface of the liquid. The ripples formed are reflected from the walls of the trough and give rise to stationary waves. To observe the ripples and to measure their wavelength, the liquid surface must be properly illuminated. This is done by completing the tuning fork circuit through the primary P of a small induction coil. The neon discharge tube T is connected to the secondary S of the induction coil. You connect the induction coil to the primary of the induction coil and the secondary is connected to the tuning fork. Every time the tuning fork circuit is made, an electric discharge passes through the neon discharge tube. Then the light from the neon tube brilliantly illuminates the liquid surface in the trough. During one vibration of the fork, there is one alternate make and break of the tuning fork circuit, giving us one view of the ripples on the liquid surface. So, the same occurs again when the fork has made one vibration during which the ripples have moved through one full wavelength. So, when the liquid surface is lit up, again as before, we get second view of the ripples which is identical with the first. So, hence the ripples appear to be stationary in their earlier position due to persistence of vision. So, due to persistence of vision, we can see the ripples as stationary. Now, you measure the wavelength of the ripples on the surface of liquid. The frequency with which the liquid surface is lit up is the same as that of tuning fork and therefore of the ripples. A graph paper is placed at the bottom of the trough and the distance between a large number of ripples is measured. From this, the mean wavelength lambda is determined. So, in the induction coil and the neon discharge tube arrangement is only to measure the wavelength of the ripples.